Hello, dear students. Hey, by the way, if you like this video, click below and give me a like and subscribe to my channel if you like. I'm just kidding, but maybe one day we'll do that. Today we have Proposition 10, Book 2, Proposition 10, okay? Which states, if there be a line and it be divided in half and then a part be added to it, that the square on that whole line together with the added part, that square, plus the square on the added part, taken together are equal to double the square on the half plus double the square on the half together with the added part. That line, half, and the added part, the square on that. Okay? So here we have our straight line. It is bisected and there's a part added to it. Therefore, it is required to show that the square on the whole line and the added part plus the square on the added part are equal to the square on the half plus the square on the half and the added part taken together as a whole. So the square on this whole thing, okay? I've just colored the lines. I'm not sure how much it's going to help right now. So we've got to pay close attention. It's a very cool prop, and a lot of it is on the construction of it, okay? So here's our original line divided in half. Let's go something like that, divided in half. We're going to make perpendicular. We know we can do that, given a line and a point on it, to draw a line perpendicular. Then to cut from the greater line, a line equal to the lesser, so equal to either of these because they're equal to each other. So let that be about so. And then connect these. And then let's connect, what color do I want this one to be in the end? I guess we can make this blue. Connect these. All right. And then let's draw some parallel lines here. Let's draw a line parallel to this line from this point. And then let's draw a line parallel to this line from this point. Okay, I guess we'll do something like this for now. Like I said, I'm not sure how much this color is going to help. Okay, now, because we have two parallel lines and a line falling upon it, we know that these interior angles are going to equal to two right angles. Okay, so that means part of this one together with this one are going to be less than two right angles. If these holes equal two right angles, obviously these two are less than two right angles. And we know if we have two straight lines and a line falling upon them creating interior angles less than two right angles, those two straight lines will eventually meet. So let them meet. And let them meet, here I'm going to do this one in black. Okay. Great. All right, what else we want to do? Let's connect. I'll use maybe blue here. Like I said, I don't know how much these colors are going to help. Good. Now that's the figure you want to end up with, okay? Now, remember, we drew this equal to this and equal to that. All right? So here we have, look at this green thing here, green triangle. We have an isosceles triangle, therefore the angles at the base are equal. We know that. Likewise here, triangle here, isosceles triangle, therefore the angles at the base are equal. And remember, we drew this as a right angle. So here you have a triangle, and we know that the interior angles of a triangle equal to two right angles. This is a right angle, therefore this and this are a right angle. But this is equal to this, therefore each of them are half of a right angle. Same thing over here. This is drawn at right angles, when we drew that. If this is a right angle, that's a right angle, because when you have a line falling upon a line, it creates either two right angles or adjacent angles equal to two right angles. So two right angles. Triangle, isosceles, angles at the base are equal. This is right, therefore this plus this is right, but they're equal. Therefore this is half of a right angle, and this is a half of a right angle. If this is half a right angle, and this is a half a right angle, this is a whole right angle. Great, we're going to need that whole right angle later on, so let me erase that thing. Okay, now look, oops. This is half right angle, and it's equal to this. because these are vertical angles. Therefore, this is half a right angle, okay? And this is a right angle because here you have two parallel lines and a line falling upon them, creating alternate angles equal. This, alternate angles. And one of the alternate angles is right, therefore the one equal to it is also going to be right. So that's a right angle. If this is a right angle, and this is half a right angle, this must be a half a right angle because the three of them added together are equal to two right angles. Right angle plus this are going to equal two right angles. Therefore, this plus this is going to equal one right angle. And this is equal to this. Therefore, each of them are equal to half a right angle since taken together they're equal to one. So this is equal to this. Great! Now you have a triangle with the bases being equal. We know, therefore, that, it's important right here, that this line is equal to this line. Okay? Great! What else do we want to get going on here? We should be okay. We want to show this. Oh, let's show that this is equal to this, okay? How do we know that? Let's say we know that this is a right angle because this is a parallelogram and this is a right angle. Opposite angles of a parallelogram are equal, therefore this is equal to this, and this is a right angle, therefore that's a right angle, okay? And here you have two lines with a straight line falling upon them. They're going to create two parallel lines, therefore the interior angle is equal to two right angles. We know that. And this is one, therefore this is a right angle here. Okay? And this was proven earlier to be half of a right angle, therefore this is also half of a right angle. Okay? And this was proven to be half of a right angle. Now you have a triangle with the angles at the base being equal because they're both half of a right angle. Okay? If the angles at the base are equal, the sides are equal. It's an isosceles triangle. So this big old thing is an isosceles triangle. Great! Now we have all the elements we need to get cracking. This is a very cool problem. Pay attention! Triangle, right angle. Therefore, the square on the hypotenuse is equal to the squares on the sides added together. But this is equal to this, therefore this square is equal to this. Therefore, twice this square is equal to this square and this square. Or the square on this and the square on this. Sorry, I should say it that way. So twice the square on this is equal to the square on this and the square on this, because this line is equal to this line. Well, if the square on this is equal to the square on this and the square on this, and the square on this and the square on this is twice the square on this, the square on this is equal to twice the square on this. Two things equal to the same thing are equal to each other. Review that in the video. I know I said it fast, but it's pretty easy. Right angle triangle, the square on the hypotenuse is equal to the square on the sides, but these two sides are equal, therefore the square on the hypotenuse is equal to double the square on one of the sides, obviously. Okay? So, square on this is equal to double the square on this. Remember that. That's going to help us later on. Now, let's go here, I guess for now. Let's look at this triangle. Same thing. Right angle triangle, two sides being equal. The square on the hypotenuse, because it's a right angle triangle, the square on the hypotenuse is going to be equal to the squares on the sides added together, but the two sides are equal. Therefore, the square on the hypotenuse is equal to double the squares on one of the sides, since the two sides are equal. Okay? But this is equal to this. This line is equal to this line. Opposite sides of a parallelogram are equal. So if the square on this is equal to double the square on this, it's also equal to the double the square on this, because the two sides are equal. So here you have the square on this is equal to double the square on this, and the square on this is equal to double the square on this. But look at these two lines where we had the squares. This is the hypotenuse of this triangle, and this is the hypotenuse of this triangle, but it's also two sides of this triangle. Cool. If you can follow that, I'll be happy. And this triangle is a right angle triangle. So the square on the hypotenuse is equal to the squares on the sides. But the square on this side is equal to double the square on this. And the square on this side is equal to double the square on this. Therefore, the square on the hypotenuse is also equal to double the square on this and double the square on this added together. Great, but now look at this square. This square on this hypotenuse of this triangle. Sorry, did I say look at this square? Look at this triangle. The square on the hypotenuse is equal to the squares on the sides, because it's a right angle triangle. I showed that already, that this is right because that's right. Okay? So if the square on this is equal to double the square on this and double the square on this, and also the square on this is equal to the square on this and the square on this in this triangle, then the square on this triangle and the square on this triangle, sorry, the square on this side of this triangle and the square on this side of this triangle is also going to be equal to double the square on this and double the square on this. Okay? But this is equal to this because this is an isosceles triangle. We prove that. Okay? So if the square on this and the square on this is equal to double the square on this and double the square on this, but the square on this is equal to the square on this, we can also say, two things being equal, same thing, equal to each other, the square on this plus the square on this is equal to double the square on this and double the square on this. But the square on this is the square on that whole line together with the added part. And the square on this is the square on the added part. And the square, double the square on this is double the square on the half. And double the square on this is double the square on the half and the added part taken together as a whole. Therefore, we have shown that if there be a line and it be divided and you add a part to it, that the square on that whole line together with the added part and the square on the added part is equal to double the square on the half and double the square on the half taken together with the added part. Quod erat demonstrandum. I know it seems difficult, but you do it a couple times and it'll be easy, okay? Bye-bye. Ciao.